All right, so for this third section, you should be given a fairly large packet that has a bunch of graphs on it and a bunch of blanks that you have to fill in. And so what you guys are going to be doing is you're going to take the information that we started out doing with chapter 1, learning kind of, what does it mean to be increasing, decreasing, bounded, anything like that, um, including our domain and range that we talked about at the beginning of the year. And what I want you to do is I want you to identify the characteristics of these 10 basic functions. These basic functions that we're going to be doing, the more you know about them, the easier it gets to be able to do our transformations, which we'll be doing in the next section. So we just want to become very familiar with the graphs. I'm just going to do one here for an example for you so you know what you're doing. And then you definitely want to get in some small groups and work through them. You will notice that Google Classroom does have the solutions to it. However, do not use that. Make sure that you go through and do these on your own and then go back and check your answers. Just because of the special circumstances that we have here, that's why I put those out for you guys. So anyway, one of those basic functions is a linear function. So we're looking at f of x is equal to x. Real basic here, as far as a linear function goes, I've got a slope of 1 with a y-intercept at 0. So as far as our domain goes, we're talking about all real numbers. I can put anything in for x, and as a result then I'm going to get all real numbers for the range as well. Feel free, if you want to use interval notation instead, you're more than welcome to do that, whatever you, I guess, feel most comfortable doing. As far as the roots go, when we talk about roots, we're talking about x-intercepts. And at this case here, the x-intercept would be at 0, since it's going through your origin. The y-intercept is going to be 0, 0. As far as this graph being continuous, it is. There are no breaks in it. There's no holes or anything like that. This graph is never decreasing. So as far as an interval for where it's decreasing, there's none. It is increasing for all real numbers. So it's increasing on all real numbers, or for the interval from negative infinity to infinity. The linear function that we have here is considered an odd function. It does have that rotation symmetry. It is not bounded. And minimum and maximum, there are none in this case. There are no asymptotes in this case, which leads us then to our end behavior, which is talking about our limits. So the limit as our function of f of x goes to positive infinity, our y value is also going towards positive infinity. So as I go to the right here, it's going up. As I go to the left, my y, it's decreasing. So my limit as x approaches negative infinity of our function f of x is going to equal negative infinity. So what you're going to do is you're going to go through these 10 different basic functions. I even threw a different one on there, which is talking about the logistic function. And that's more so dealing with like a population that eventually plateaus. And we talk about that once we get into exponential functions, but just thought I'd throw that out there, just having you guys kind of look at the graph and being able to come up with the characteristics. So definitely do these on your own, and then once you're done with that, take a look at the answer keys and see how you did.